Hello and welcome to another ramble with me. We are rambling about IEB's paper 2 from May 2025. Today we're looking at question 5a. In the diagram below, triangles ABC and PQR are drawn. The angle A is equal to the angle P, the angle B is equal to the angle Q, and the angle C is equal to the angle R. So in other words, triangle ABC and triangle PQR are equiangular. Then we're told DE is drawn such that AD is equal to PQ and AE is equal to PR. So, right, okay, let me hold my horses. Then reasons must be given in this question. So we know that this is equal to this is equal to this, and this is equal to this. We furthermore know that AD is equal to PQ and AE is equal to PR. Right. So we are asked, why is triangle ADE congruent to triangle PQR? Right. So congruency of two triangles we prove using one of four options. SSS, i.e. side, side, side. So the sides are all equal to each other. The corresponding sides are equal to each other. SAS, side angle included side. AAS, and the last one is RHS, which would be if you had a right angled triangle and the hypotenuses are equal and another side is equal. In this case, we've got the SAS case, right? We've got this side is equal to this side is equal to this side, and the included angle is also equal. So that would be the proof. We would say that AD is equal to PQ, which we were given. AE is equal to PR, which we were also given. And then finally, we were told that A is equal to P, the angles. We were given that as well. And so therefore, triangle ADE is congruent to triangle PQR, and that is for the reason SAS. Okay, good. So we now know that this triangle is equivalent to this triangle over here. So then we're asked to prove that AB over PQ is equal to AC over PR. So that would be the same as proving that AB over AD is equal to AC over AE, right? Because PQ is the same as AD and PR is the same as AE. And so for me, that is going in the direction of proving that this triangle is similar to this triangle. Let me think about that. Yeah, because we don't know. Oh, wow, okay, sorry. So we know that this angle is this angle and this angle is this angle. So we have found out that this is heart and this is star. So yeah, we can prove that these are similar. So I'm gonna go ahead and do that. Right. So we know that angle ADE is equal to angle Q because of the fact that these two triangles are congruent. Okay. And similarly, we know that angle AED is equal to angle PRQ. And that is also because of the congruency of these two. right? And so therefore, and we know that triangle A is common to triangle ADE and triangle ABC. Okay, and so what we've managed to prove there, oh, okay, no, sorry, we haven't proven anything yet. Oh, guys, I don't know where my mojo is today. Where's my mojo? Where's my mojo? Okay, so all we've done now is we've shown that, okay, this is also heart, this is also triangle. Now we can prove that these two are similar. Okay, so let me actually just make it very clear to myself what I'm doing, because now I'm just getting confused for no reason at all. Okay, so that was our starting point. So now we say in triangle ADE and triangle ABC, okay, we have A is common to both of them. We have angle D is equal to angle B, which is sort of given, okay, because we know that angle D is equal to angle Q, which is equal to angle B, and we were told that Q is equal to B. So in a way, it's kind of given. And then finally, we know that angle E is equal to angle C, also kind of indirectly given, because angle E, we've just shown, is equal to angle R, right? That's what we were talking about there. And we know that R is equal to C. We were given that there, right? So, oh, no, I don't need this anymore. So therefore, triangle ADE is similar to triangle ABC, and that's because of equiangular triangles. I don't know what happened to good old AAA, but anyway. And so, right, what are we interested in? We're interested in AB and AC, AB and AC, and those correspond to AD and AE as we expected. So we're going to say AB over AD, right, first two over first two, is equal to AC over, so last two over last two, AE, which would be this one, right? And that's because of the similarity that we just proved. Okay, right. And we know that AD is equal to PQ and AE is equal to PR. So we're just going to go ahead and state that. So we know that AD is equal to PQ and AE is equal to PR, and that's because of the congruency that we proved here, which I am just going to take the leisure to duplicate. Okay, right, and let's just sanity check ourselves here. So we've got AD over PQ and AE over PR, so that works. Well, AE is equal to PR, sorry. So therefore, what we can then say is AB over PQ is the same as AC over PR. If we replace the AD with PQ and replace the AE with PR, which is what we were required to prove. And I think that's the end of that question. So let's have a look at how the memo's gone about it. So for the first question, all they've said is SAS. That's all they wanted. So this little spiel of given wasn't even the point. Right. And then over here, let's try and follow their proof. So they have angle D is equal to angle Q, and angle B is equal to angle D, okay, right, so D is equal to Q because of the congruent triangles, and then B is equal to D as a result because we know that B is equal to Q, and so therefore DE is parallel to BC because the corresponding angles are equal. Then they say AB over AD is equal to AC over AE, and the reason that they give is line parallel one side triangle. I don't know what reason that is. I've never seen it in my life. Yeah, no. I'm not even gonna lie to you. I don't know. I don't know. Oh, there's another question. Oh, that's 5B. Are these... Oh, I think they're separate. Okay. Sorry, just had a bit of a panic attack. I got a glimpse of the answer to the next question, but it's a separate question. Anyway, so if you want to see what the thing that was shocking me is, come through for the next video. Right, let's leave it at that. I don't know what to say about the answer in the memo. I don't want to lie. But I'm confident of the answer that I gave. So, yeah, cool. Beans.